So let's discuss this example number 6. There's a cone inscribed in a sphere with the vertices and the base, the circular base touches on the sphere surface. Okay, so definitely you will have to imagine how does this new object looks like before you can look into all the other information given in the question. So if you have this particular sphere, so then you have a cone inside it. That's what it's mentioned by inscribed. So this vertex and the circular base is already, or mentioned over here, it's touch on the sphere surface. We can use other color in here, maybe just red, saying that this actually touches on the sphere as well as this circular base. So you have something like this. So it should be 3D like this. That is how this object looks like in our question. So we take a look into the question itself. You are given that the radius of the sphere is equal to A, right? And then you are also mentioned that you need to show that the volume of this particular, is it the volume of the cone? Yes, it's the volume of the cone must equal to given in the question. So like I mentioned in the previous video, there's a lot of this show proof kind of question, alright? And lastly, you will need to find the height so that the cone is maximized. So for the second part, it's very easy. You need to find the height where the volume is maximized, meaning to say that we can put it somewhere in the question paper. If you are in examination, the dv over the h is equal to 0. Definitely you can find what is your h using that one. So that will be the second part of this question. So let's keep it there. And then if you notice the first part of the question, you need to show that the volume of the cone equals to something with A and H. That is already shown that the volume formula is written in variable H only. Hence you can differentiate that and get the answer for this second part already, even if you cannot answer the first part. So that is the flexibility, how we can help you in the examination. But learning this from the early stages, definitely you would like to answer from the first part and then goes to the second part, right? So let's try to draw this in a much more can you say it's lookable or much more easier look. You have this sphere. From the side it looks like a circle, and then this will be the cone inside the sphere. It's like a triangle if you look it from the side. Okay, so that didn't match, but it's okay. And if you have this one, the center of the sphere, and then the center goes towards the surface of the sphere, is actually the radius of the sphere. Okay, and then this part is from top to this bottom is the height of the cone. I like to use HC. This subscript is very important in a lot of our mix and match or combination of more than one objects. And this small part is actually the radius of the cone. Okay, so the question has already given us a constraint. Which one is it? It's actually the radius of the sphere equals to A. In this sense, although A is another letter, people might say that it's another variable, but actually a in itself is a constant. It can be any number as long as you can write it in a. So how can we, you know that the formula for the volume of a cone, again let's use the upper side, since definitely it will be provided in the examination and along with the question. V is equal to 1 over 3 pi r square h. So if you would like to write this formula in the form that is shown in the first part of the question, you need to change the r into a and h. So let's write our purpose over there in terms of a and h. This one is obtained from the first part of the question, okay? So just that maybe some has forgotten, or just refer to your lecture note. This is the first part of the question itself, alright? Show that v is equal to 1 over 3. There's an a, there's an h over there with a lot of parentheses, okay? So this is the volume of the cone. So don't stray away from this one. Everything over here is the cone, and cone. Meaning, how can we relate this RC with this A? That is how we tackle this first part of question. Definitely, if you are going to rewrite this one in terms of A, in terms of H, you will actually utilize the constraint given in the question. Alright. So if you are looking, every time you are looking at a triangle, definitely you are thinking a lot about triangular stuff, which includes theorem Pythagoras, trigonometry, and so on. But for this one, it's pretty much theorem Pythagoras, because as you can see over here, this part is your RC, and for you to relate it with A and H, definitely you will need this hypotenuse, and this is a right triangle, so that it becomes a theorem Pythagoras, and then you will have this H. Okay, so if you are looking at theorem Pythagoras, then the triangle that we are looking at is actually this side. Let's use other color, maybe how about the purple? Okay, so this is the triangle that we are talking about. Right, let's go back to black. Alright, so now that we have, this is the A, this is the R of the cone, the one that our target is, and then this small vertical side of the purple triangle, what is this value? So we know that from top to bottom over here is actually the height of the cone, and at the same time we do know that if this one is the radius of the cone, this one is the radius of the sphere, this one is also from the center towards the surface is also radius of the sphere. So this small part is actually the H minus with your A. So you have your A over here, you have H minus A, then you have your RC. Then what are you waiting for? It's going to be let's rewrite it in the subscript form first. RC square is equal to the hypotenuse, which is RS square, minus with well, let's call this one as an X square first. Okay, then since the radius of the sphere is called A, now we can use this one as just simply R. So R square is equal to A square minus with this part is going to be since there's only one height, so it will be H is ample enough, minus A square. Okay, So now that we have everything like this, you can actually expand this to become a square minus with a square, and then negative 2ah, as well as plus with h square. So I'm not going to expand it here because it's pretty much really doable at your level. So all in all, it will become 2ah minus h, and then a set over here from the left hand side r. So now that you have your r for this, then your v is equal to 1 over 3 pi r square h can be rewritten as 1 over 3 pi 2ah minus h multiply with h, and then you can expand it to become 1 over 3 pi 2ah square. Oh sorry, I forgot, this one should be h square. This one is h square, and then minus h cube, as in the first part of the question. Okay, now that we have tackled the first part, that is a lot of work, but we think that you will be able to manage this one, no worries. Maybe on the first try it will be a bit hard, but on the second, on the third try, you will be able to get it. So this one is all about using the constraint and then relating on how to show the formula. If the first part of the question is not there, let's say that the question simply asks you to find what is the height when the volume of the cone is maximum, you are not necessarily have to use this particular really a bit complicated diagram and geometrical problem over here. It can be something else. Okay, this one is done basically on the request of the question itself, but otherwise it's really flexible on how we can apply or use the constraint to rewrite the formula into a single variable term like this. Okay, now that we have our v, what are we waiting for? We can do this differentiation pretty swiftly. You will get 1 over 3 pi, and then this one will become 4ah minus with 3h square equals to 0. Equals to 0 is because of the concept you would like to have maximum volume. Then rearranging this is simply a quadratic function. You know that this 1 over 3 pi will vanish because this side is equal to 0, and then you only have 4ah minus 3h square equal to 0, and you will get h is equal to either 0 or h is equal to 4 over 3a. So definitely when you are talking about a real object exists in 3D space, h equal to 0 is rejected, or maybe negative value is rejected. You cannot count things with negative or 0. Then your final answer for this question is h equals to 4 over 3a to have the maximum volume for the cone inscribed in the sphere.